So, good afternoon to you all. My name is Alan Govard, and I was asked to spend like 30 minutes together with you going through some, not the basic aspects of radiology, but through, let's say, the basic aspects of an X-ray machine. Not explaining also as little as possible on the technical side, but more or less the parameters and the points on let's say, the application of the X-ray machine, okay? So trying to explain you a little bit what is available, what's not available, what are things and points to think about. And also, if we still find the time, also I will put a little add-on specifically on X-ray grids. I have to apologize that I will only be able to present it in English, so my Finnish is non-existent. So. But I hope you can follow me. I was told in Finland, most people also understand English. So. As you see as well on the first presentation slide, I have a couple of slides, of course, to run through. The company Examine is a group of companies which are mainly based in Europe, also in the United States, founded in Germany. And we deal only for about 30, 40 years with digital X-ray in the human field, veterinary field, and specifically also something in between, which we call the military field. So most of the things we have to construct and think about have to be very robust, very practical. Now, explanation is that I'm actually in the group responsible for the veterinary department. I've been doing digital X-ray from the very start of digital X-ray when it came available actually for the veterinary market, which is now more than 20 years ago. And I'm actually situated, based in Switzerland, near Zurich. And I would say that the world is my place where I travel to, so we end up with a lot of different situations, and I hope to transfer that a little bit to you. Just very shortly as well, so you see the different ranges of specifications of the markets where we deal with. As you see, most of them is more related with the human side of it, but the veterinary for us is, I have to say, extremely important. To give you a rough idea, what we do in the human field worldwide, we do about equally an amount for the veterinary, also on the world market, okay? So it's very, very important for us. A little bit about the company, a little map. There you see the main building. Main office is based in Stuttgart, which is in the southern part of Germany. And it's an area where we will find actually most medical-related companies in Germany, also from medical instruments, things like that. The Black Forest area seems to be very attractive for a lot of companies there. Of course, we're here now in Finland, and in Finland, Examine does not have a direct office, and we deal actually with local Finnish companies who are specialized in X-ray, who are specialized in the veterinary market specifically, and who are not just people who talk, but also can fix something when needed. So most of these people also are certified then by Examine. They have to follow certain standards, have to follow certain courses, be able to do certain things when you ask them and when we ask them also. So in this case, we are talking about Röntgen Techno. Mr. Ville Ekros, the owner of the company, is sitting in the backside, so maybe you know him already. Now, the presentation itself belongs to a part of, let's say, not to do only with what we build and sell and support in the market, but also we have also a large, let's say, division which we call the Academy. X stands for Examine. And we actually make courses all over the world. On a yearly basis, for veterinary alone, we have about over 30 courses. So it's quite a lot. And they vary. You'll see a few examples, like in Sao Paulo, Brazil. We have the same one this year, is to do with equine sports medicine, for example. Speakers are mainly people also from universities. If you go to like South Africa, Kalahari, was more related to exotic animals in the wild. So for that also, our experience for the military operations, in-field X-raying was very important. But like you will see on the courses there, the little forum in Oslo, we do regular courses for small animal, as we do also here, but could be any topic related to medical imaging. So also this course is, of course, a part of it. Now, generator in general, everybody knows an X-ray generator, and they all look alike. They all hopefully have a table. They have a generator built inside. They have somewhere where we can produce some light and you can produce an X-ray image. But there's a lot of aspects in X-ray which are difficult to follow for a lot of people. And you have to rely upon experience. It's not always easy to come up to a decision. So here you see the question mark is always like once you get a brochure in your hand, for example, or you see a machine, you ask, what does the machine do for me? Well, just putting a few of the parameters, and it's endless to be honest. People are talking about the power in kilovolt, milliamps, MAS. We all know about that. You also see the kilowatt. What is kilowatt? FFD, film focus distance. Is it 1 meter? Is it 75 centimeters? Is it variable? Is it less or more? APR is in atomic programs. What do you mean by that? For example, does it have it? Does it not have it? And a little bit about the tube and the table, and then also the focus. The focus, what do you mean by focus? So there's a lot of points, and if you add them all up, it can be quite confusing. Because if you have one good value for one, it could be bad for the other one. So where's the compromise? Well, I've tried a little bit to put some pointers in here. Is that first a little bit about a portable X-ray machine, because also in mixed practices sometimes, and in some countries much more than in others, they would sometimes opt for a portable X-ray unit also for small animals. And here you see on the diagrams, I've put in, for example, EQ is from equine, it could be also small animal. In case you need a portable one, even also for surgery rooms, for example, you would take a portable one, take a cassette into the surgery room, and actually, as during the operation, take some X-rays. So there you need a portable solution as well. Could be battery operated, power operated, and then you see the little balance. Then you see, okay, what to decide now. Then you can see on the one side, you need a small focus to get resolution. The machine does not need to be too heavy, otherwise, it will be unstable. And on the other hand, I need a lot of power. But more power makes the machine again heavier, and also the focal point is being not so small anymore, so the resolution can also be worse. So it's like always handling and juggling with parameters of an X-ray machine. Just as an explanation. Here you see, for example, small animal, then we go more to stationary, not necessarily, but most of the time the stationary machine. So SA, small animal, static is stationary machine. And there you see that the weight of the machine is not so much of an issue. It has to do, of course, also with the machine construction itself. Can I actually have a long enough table? That's important. Is it high enough? Is it low enough? But also the power of the machine, and then, of course, the more power you need in the machine, it becomes, on the other side, also more expensive, for example. Okay, this is also related. Where's, again, the threshold? Where's the parameters which are useful for me or not? And here you see, for example, in the red box, something I find in the small animal apartment always a criteria for me is like you have to try to find out actually where the limits are. So you have to look for the extremes in X-ray. So in small animals, it's very important to find a machine which I think is, for small animal, extremely important, have an extremely short exposure time. Because if you have a long exposure time, animals breed, they move, they are in stress, they have dyspnea, whatever, and you will actually get blurriness. So you have to try to avoid that. And then the penetration power, well, anything, we don't need too much kilovolt on a machine, to be honest. You just need enough to get through the animal. Most animals, you can actually get through them if you have something around 70 kilovolts, sometimes 80 kilovolts. So within that range, you do not need 140 kilovolt to X-ray, let's say, a normal animal. And then you go to the other point is a small focus, because focus is detail. It's another point. And then again, you're also looking for the MAS values. Well, to be honest, the MAS, even with portables, or that's the dose of the machine, not the power, you will be able to X-ray most small animals with values between 5 to 8 MAS. Some people might have in their mind also the double of that, something like 20 MAS. Well, normally it's not so much needed, as we have something which we're going to talk about also in, let's say, the last slides, about talking about grids. So we can reduce also those in certain ways. And in the bottom, actually, just on here, you will see which normally you never find on any X-ray machine. And that's something you need to try to find out, because it's not that your machine has, let's say, 100 kilovolt and it makes 400 milliamps. Well, that's nice. It will probably, but not at the same time. So you need to find out the real power of the machine. And as you can see here, if I move from one to the other values, if the kilovolt goes up and up and up, you will see actually that the milliamps, real milliamps, which the machine is offering you, are going down and down and down. Okay? So different machines have different calculations, and the good ones will allow you to use as high much kilovolt with still actually high milliamps. And there's also a jump from a small focus to a large focus. The focal point of a machine, why do they have two, is, well, normally you should be using only the lowest one. It's simply protection from the machine. The focal point is built on the anode of a machine, and the anode is where the electrons, electricity, fall into, produce a lot of heat, and where the X-rays come out eventually. But because of the heat factor, the more power you use, this is bad for the machine. It can actually destroy the machine if it becomes too hot. Okay? So that's why they sometimes use a larger focus, where instead, like with a loop on the sun, instead of burning the paper and you put a larger focus and not so sharp anymore, it doesn't become so hot anymore, so the machine is actually protected, just like you wouldn't be able, actually with sunlight and a little lens, to put paper on fire when it's not focused sharp enough on the paper. And that's why some machines jump very easily and very fast to a large focus, but that diminishes your resolution and detail of your X-ray, which also you do not want to know. Again, a balance. Now, to find here where that machine and how it reacts and as from which value it jumps to a larger focus, some of them do that from a very low kilovolt, for example, others do from a higher kilovolt. It's very difficult to know. And sometimes you actually have to measure it because it's not be found on paper. The companies who manufacture the X-ray machine do not want to tell you also, because there's simply like, I would say, I wouldn't say a million, but thousands and thousands of X-ray machines and X-ray tubes on the market, and sometimes it's very difficult to find out which type has been built in which machine. Okay, so in the end, when you buy the machine, you have it installed and you start using it, then you will find out. But sometimes then that's too late. So it's always interesting to try to find out and get a good answer on it. Good. And here we have like the mixed practice I talked about. So here all comes together, it makes it even more difficult sometimes to make a good choice. If you're going for a portable, how portable does it have to be? Do I need to go and run to in the field? Is it just to the next room? Do I have a stand or do I have to hand hold it? It plays all a role, so again, fine balance. Now, the advantage of modern technology, I cannot emphasize enough. Modern technology means as well, you know, with everything that's manufactured from like PCs to cars to whatever, everything has an exponential growth in what, let's say, the capabilities and let's say the advantage of especially on hardware and also software can offer you is that if we have an X-ray machine which is 50 years old, it still works, it's fine. I mean, these machines still exist in the market. I've seen some which are even older, even with porcelain knobs, things like that, which were pre-war. So this is nice, you have one and it lasts, but it will never perform like, let's say, an X-ray machine which is built today or tomorrow might be again an improvement on that. Okay? So there's like a certain evolution. An X-ray machine, I would say that the intuitivity of the machine is important. As a veterinarian, you want to focus on the animal, not on the X-ray machine. So intuition is actually from the machine very important. It needs to be automated. It needs to be automated in such a way that when you put the animal on and you say, I want to take this shot, everything is actually preset for you. So with a simple press of the button, then you will actually have your picture, and probably also in the way you like it. It has to be future-proof, so that means also an advantage, and more machines which are modern now are built in that way, so they are modular, so that means that certain components can be adapted. Older machines, they are pretty much closed and fixed, so if it's one part is broken, it's very difficult to actually get a replacement part and a replacement part which is also suitable for your machine. So the modalities, the future-proof, intuitivity is important. And then there's also, these days, everything is digital, so also X-ray machines. Everybody knows already also about PACS and DICOM, so if you have all that already integrated into your X-ray machine, it saves you a lot of money of, let's say, having to buy that as a third factor and integrating yourself. Integration is always possible, I would say, but it's not always easy. And if you have to spend the money and the time of trying to integrate yourself, it might be very disappointing. So if you have an integrated machine with software which is open to the rest of the world to receive data from your clinic software and also send out any data and imaging towards, let's say, other clinics or other computers within your clinic, this is also a big advantage. And we're talking with software about the acquisition process, paxing is archiving, and also viewing, so and vice versa. Now, very shortly on the X-ray machine. In the past, powerful X-ray machines, they needed lots of power. As you see, we are talking about machines 125 kilovolt, 400 to 600 milliamps. These were like standard X-ray machines with which you could actually X-ray all dogs, and all cats of course, but dogs are the most difficult, also larger ones. Also hip dysplasia from very solid muscular dogs. These are the minimum powers I would advise, simply because you will also be able with these settings to have very short exposure times. And anything around 00, well below 006, but ideally 003, means that any movement of the animal, also like breathing, but any other movement will not be shown on the picture as blurriness, so you'll always have a sharp picture. So for that reason alone, this power is needed. No, in the past we used three-phase electricity for that. That means if you had a machine, you need to have from the machine actually very large power in it and an adaptation. As you know, in the socket you have 220 volt and it's monophase, so that means you have an oscillation in there. This is the oscillation. In X-ray we can only use the tops of the maximum of the power, so it's only two small moments within one cycle you can use to produce X-rays. And the negative sides is actually dangerous, so we rectify that, we take that away. And in three-phase, what you do is actually you build up more oscillations, so 3 times as many. So with 3 times as many, you can also produce much more power. Now, bad thing was in the past, to be able to do that, you have to practically rebuild the electrical network of your clinic, sometimes even down to the streets where you have the main line from electricity, to be able to get this amount of power into your clinic for this machine. And that has changed a little bit. It has changed because since a long time, but has been again and again developed in a better way, we also have the high frequency machines. And high frequency simply means, okay, we still have these oscillations, but instead of using the normal pulses of electricity, which is 60 or rectified 120 pulses per second, we are now having 100,000 pulses per second. So as you see in this oscillation, we no longer jump from one top to the other, but we can actually have quite a stable output line in time. That's important. It's a little bit technical, but I'll keep it to that. And it's actually also, there's much more behind that. It is first of all very important because the technology means now that the machine can be wall plugged. That means you have 220 volt, you put the plug actually of the X-ray machine, put it in the wall, start X-raying, and you will also have the high power, which was previously not possible. So it opened up, especially for the veterinary, especially also for other fields like mobile fields and mobile clinics, quite a lot of options and allowed us to do applications mobile also in clinics, even in airplanes, even in trucks, it's all possible. That has been quite a relief. So with 100,000 pulses, full rectified still, HF, the advantage is, first of all, less expensive. You don't have to rebuild your clinic, that's one part of it. Also the X-ray machines themselves, they are less expensive to build. It's wall plugged, also they are not so big, so the generators can easily be fit underneath the table. You don't see it as a second cupboard into the X-ray room or into another room. They actually have a very long shelf life, so these machines, to be honest, if it's taken care of and calibrated on a regular base and nothing weird happens to it, then you will see that it can last up to 30, 40 years, which is quite a long time. And we still have the short exposure times. With the machine you see here, I've put very short pictures on it, actually just to show to you that this is the machine I was talking about. It's high frequency, fully integrated, has packs on board, touch screen, so everything is regulated from one console. So it's very powerful, X-ray images. It's even with the DR panel inside, so quite a large one as well. So it's quite easy to manipulate. So you can focus mainly on the animal. I'll run through that because you will see that most of these items are dealt with. Also this with software, having a PAC software on board instead of just the control software of the generator gives you the advantage also again of being able to receive the data and even the X-ray settings and the X-ray views from your clinic software if that's available in your clinic. The machine actually when you start it up will automatically absorb the data and actually sequentially will put them in a list for you to X-ray one after the other. So you don't have to retype actually the full data into the X-ray machine again. In the human field, this is more important in veterinary because in the human field, in larger clinics, most of the mistakes are done actually for losing pictures by entering wrong patient and wrong owner data inside. Even a typing failure or just a deviation of it can already be sufficient for some data to get lost, not to be found again. So if you don't have to retype it again, you actually minimize the failure data, plus also the workflow in your clinic becomes much easier. Losing time sitting typing, sometimes the typing can take longer than actually the taking of the X-ray machine. So again, better to focus on the animal. You have the possibility also of viewing the image in high resolution on the generator itself. Some clinics is sufficient. Many other clinics, I would say, like in other Scandinavian countries in the veterinary, most of these machines are installed with secondary monitors as well. Inside the X-ray room, but also outside the X-ray room, like in Denmark, Norway, typically they would have actually extra monitors. And they work as a slave monitor, so you'll see the same functionality, same software, same control. So you can actually, when you position the animal and it's free, you can actually all leave the X-ray room, take the X-ray and go back again as well. Outside you will see exactly what you are doing. So this is also possible. And then also sending the images outside. You archive them. Most of these systems, they have a RAID 1 PACS archive, which means that all the data are actually automatically backed up at any time within one station, and that can also be updated to a RAID 4, for example, where the data are synchronized between computers which are not in the same room or not even in the same clinic or in the cloud or whatever. In Switzerland, we cannot put them in the cloud, for example, because the government does not allow medical data, even for veterinary, to be sent outside the country, like on computers in China or the US, which is often the case. Okay? Because if something goes wrong, well, you do not have any law behind you in saying, I need my images back. These are mine, these are private data. So there's some reasons we have to take care of, but again, it's modular, can be adjusted. The little diagram is quite small, but this is a little bit about system integration, so I'll move to this one. Here you see a little bit what these PACS softwares can do and how modular it is. So you have here the acquisition part, PACS part, and viewing part. So you need all three of them, of course, but sometimes you already in your clinic have something, so you would say I already have a PACS software, okay, and you already have computers where you can view digital imaging, whether it's also ultrasounds, endoscopes, video films, whatever, X-rays, CTs, MRI. If you already have that, then you can actually go in with a simple acquisition software and a digital component, whether that's X-ray or CT or scopes or any other devices. You can come as a simple acquisition part into an existing PACS. And this is done by DICOM protocol, and it means some protocols need to be connected so they can speak the same language. And it's not because very important that you have the label DICOM that they will be able to do that. DICOM doesn't mean anything unless you actually try to find out what it means for that one single part within the system. Okay? Every part within the system, whether it's hardware, software, a certain function, a certain procedure that is built in, all these need to have a separate DICOM statement. So if you have from many developers who make these products, you will have actually a big case of paper declaring that everything is DICOM, and they have to redo that every time they make a new development. So it's not because they had it once, they need to continue to do that. On the other side also, you will see that if you already have a device, in this case, for example, a CT, which is also sending DICOM pictures out, any software which is PACS and DICOM can also simply use as, instead of doing the acquisition, simply also archiving and then viewing. So these are like 3 blocks, and these blocks you can, have them all together or separately, but they can all be added. So This is very important. In practice, in the veterinary clinic, I would say if you get your administration data in and you have the devices in your clinic, and you can have them all sending the DICOM images, and they are put in an archive and then sent throughout where you want them, this is the most interesting. More and more in veterinary, in the past it used to be with, let's say, viewing stations within the clinic. Then it went actually to mobile viewing stations within the clinic so that people wanted to see the pictures also on their iPads, their iPhones, or any other multimedia devices. Then it also went outside the clinics, whether you work together with other clinics or you are in a veterinary group. They also want to centralize their DICOM data. And this then also means that these data need to be sent out automatically to a central device, a server somewhere within the group, and where everybody that needs to have access needs to have the access ready for them. So it goes now in the last 5 years in the veterinary world a little bit also more in that direction. Also important is people from the universities, they also work a lot of the time, or larger clinics which are more specialized, they work as referrals. So also for them it's very important to be able to have the images ready for them, so they can also in a very easy way open up the images, get our full data with the images, view them, make a direct report which is not too complicated, and actually automatically send them back. So emphasize on automatically. If things are not so done automatically, it becomes laborious, and also it is not so easy to do. Same thing for the kennel clubs when they do like evaluation of hip dysplasia. The images are too complicated to open up and to actually view them. I have seen in some centers that they go really per day to a large volume of data. For them, also the workflow is very important. Okay. Some DICOM statements, so we went through that. Detector systems, I would say today, although there's still people working with in the world with chemistry and film, in most countries by law these have been forbidden. Some countries it's still allowed, so it's very variable, but you don't see it that much anymore. Rather, those people who are still having it, instead of changing, it's maybe because the clinic is like they almost go in pension. They said maybe it's not worth the investment to do anything else, so they rather stop the X-ray business than moving on. A lot of other clinics then in the last, I would say, probably 10 years, they also would invest in CR system, digital X-ray, so they have the imaging plates, which are put in a cassette, and these are being read, more like older cassettes with film then, but still being digitized. These days, because of I would say market fluctuation plus also readily availability of systems as upgrades. I would say that because of these evolutions, practically 80%, 85% of the veterinary clinics that do invest would now invest in a DR panel. It's a little bit faster to work with. To be honest, also the image quality of DR systems have improved. So in such a way that even now with the panels, you can also reach panels which have mammographic characteristics, and they are certified even in the human field to be used with mammographic examinations. Some of these panels we also offer into the veterinary market. Okay. Performance is, again, if you go to like media and you try to evaluate panels or images or screens, even monitors, there's a lot of parameters also there involved. And again, I find that for a lot of clinics, it's also, I would say, very confusing. I mean, in the beginning, it's confusing for everybody because not all the data are, again, readily available. They should be, but they are not. There's no law saying that you have to provide all the data. But I think it's very important to know. And here you see some of the factors which we're looking at for image qualities, just a few of them. So like these FF, line pairs per millimeter, pixel size, then you have detector quantum efficiency, blah, blah. FPS, frames per second, modulated transfer function, so contrast noise ratio, bits, and megapixels. In some countries, it's very strange, like if you go like into Turkey or Spain, everybody needs to know how much megapixels does your panel have. Also, as much as you like, depends how large the panel is, and it's like your television. So instead, all these parameters, to be honest, they all hang together. And again, if you're looking for a panel, even if you say how much is the line pairs per millimeter, well, it could be fantastic. You could have like nomographic quality, but it doesn't mean anything if, for example, the FF, which is the fill factor, which is on a panel, how much of these pixels are available within that big size of a panel. One pixel might be very small, nomographic quality, but if there's big spaces in between those pixels, which are dead, then the fill factor will be maybe only 50% or 60%. So again, you will have a low quality, just comparing those two parameters. Difficult to know exactly what you're getting into. So here you see some of the lists, and this is just a few. It's only because my slide was becoming too small. I couldn't fill in more and more and more and more, so it doesn't mean anything, to be honest. What you need to find actually is you're looking for contrast details. So you need the maximum detail where you can still see the structures, so which are contrasted, and you need to be able to have those on your screen actually to be seen with as less X-ray dose as possible. So this is the most important thing that you're looking for. And that's something also which you can test yourself. These are phantom devices, little metal plates, which are so readily available. It's just like pieces of metal or a special cassette. They lay that underneath your tube. They take an X-ray with the software. So all the components together, monitors, software, processing, your panel, your X-ray machine, all added together will produce an image. And then you can read at the end, what can I do and what can I see? What's the resolution? What's the contrast? What do I see there? How much of the information that is sent by the X-ray machine I can see on the image? That's something, there are devices where you can actually measure that. Now, coming to that, it's a little bit about grids. I hope the timing is still okay. Or
few minutes on.
That's good. So going to grids, there's a lot of discussion, and recently I've heard also in Finland, is that you have scatter radiation. And for scatter radiation, there's this device which you're using that is grids. So you see here, without scattering radiation, a hip. With the grid, it clears up the picture. Scatter reduces the contrast, and because it reduces the contrast, it reduces also the detail because you don't see it. Scatter is produced, as you see, on a molecular atomic level, so you will have actually electrons coming in, hitting outer shells of an atom, within the animal, and you see that some of the electrons are pulled out. Now, these are no worry because they are absorbed because of low energy within the animal. But the other ones here, you see that which fell into, it changes actually just its path instead of going through and hitting the plate somewhere there, coming from here. You see it changes actually its direction and also its power. And if you have a lot of these being created, bouncing in all the directions, it lays a like kind of nebula on the image. Yeah? Again, here sometimes you say it's extreme. Yeah, okay. You have fat animals, you have difficult dogs, you have liquids in the thorax, in the abdomen, you have solid masses, one dog or one cat to the other. It's not always as easy as it is. So you need to be able to deal with that. So for that, very important is where do I produce scatter? Well, everywhere there is tissue. Where there's tissue, you'll produce scatter in one way or another. All tissues make it. So the more tissue I have, the more scatter I have. So if I can use the collimator down, and I create, actually I'm only X-raying smaller areas, I have less tissue, so that already reduces also the scatter, because the scatter goes in all directions. To do, collimate. Also, the density of the structure. It's not only the thickness, also how dense it is. If I X-ray a thorax, a big thorax could be quite thick. You will see that the scattering there is relatively minimal because it's lots of air. You do have bone, you have the ribs, but still it's not so dense as an abdomen or a hip. So also if you have metallic parts, with horses it's the horseshoe, sometimes metallic plates, they produce a lot of scatter because these elements inside have high density. Plays a factor. Try to avoid high density. X-ray power as well. The higher the kilovolt, the more power you put in, the electrons, the more that should shoot away. So you just need enough kilovolt to go through the animal. Don't use the 100 kilovolt for every X-ray. You will produce an X-ray, but you also produce a lot of scatter. So if you reduce, try to find out which kilovolt you just need to go through the animal with enough dose. That's more than enough. And the patient thickness overall. So you see, it's just one of the factors. You measure the thickness, and then you calculate the kilovolt and MAS. Okay? Now going through that, I'm going a little bit faster because we have metallic grids, and in the past that's what we had. So metallic grids actually would be existing are parallel lead lamels with other tissues, with other substances in between. Could be something fibrous, could be aluminium, which is then radiolucent. And that actually, as these scattered X-rays, they are granular and they actually go in all directions and they are homogeneous. So what does actually that any X-ray beam that doesn't fall under 90 degrees onto these lamels will be absorbed by lead lamels. That's what it does. And nothing more. In digital X-ray, what we have now is that instead of using these grids on a metallic part, because as you know, also some of the good X-rays will fall on these lead lamels, they are also absorbed. To compensate that, we had to increase the X-ray dose. Okay? Sometimes even by double the MAS or 10 or 12% on the kilovolt, and that alone is sometimes not possible. Then we have actually developed already since 10 years, to be honest, and many companies already have that on the software part, algorithms which actually will calculate away the scattering radiation after the image has been created. So instead of putting it between the animal and the cassette and reducing the scatter before the X-ray beams are dropping on the panel, we will do that afterwards, and we can do that also in a more efficient way actually with software than with X-ray grids. And there's a lot of studies on that. I will jump from one to the other just to make it a little bit short. And virtual grid is that here you will see that we have created two algorithms, one for contrast improvement, and that will estimate automatically with algorithms how much scatter is produced on an image. And then we'll try to imitate with the algorithms the effect of a grid. That's one. And that's exactly what metallic grids also do, but we will add also a noise reduction. That means we will see also that when you use grids, low dose, the images become a little bit more granular. And because they are more granular, they are never going to be of the same quality as they would be using no grid where you had no scatter. So, but with the software, we can actually do a noise reduction, which a grid cannot do. And then you see, for example, going through the substances, this is just a nice picture as an overview, is that where you see the 3 points, this is structure. In essence, an algorithm doesn't see a thorax, it doesn't see an abdomen, doesn't see a leg, doesn't see anything. It just sees information. And valid information are points and lines. And sometimes the lines meet, you can put X's, Y's, pluses, all kinds of weird shapes. They're always lines and they're always points. And then actually, if you go to the other one, here, scattering radiation, you see, has no structure. So that's what you see here, this fork on that, which is a little bit pointy, here, granular. That's what the noise is. And that's what scatter radiation is. So we are able actually also to take that away with algorithms. The advantage of that is that we are extracting and reducing the components of structureless noise, is that we actually create, we do not change the essential information of the structure you are trying to see, but we are making it more clear for you to see while keeping the contrast, while keeping the detail, and actually also by not having to increase the X-ray dose. In some cases, even true, because of these algorithms, we are even able to diminish the X-ray dose needed, okay? Which is always a good thing, because again, you will create again less scattering radiation in the first place. You will also have actually shorter exposure times, so also less blurriness. So overall, it's a better thing to do. That's fine. That's fine.
All right. Thank you.
Thank you so much.